right, welcome everybody. 9CI Designstream 005. It's been a couple weeks since our last stream. Hopefully we'll be getting back into a more regular pace here. On this design stream, we are talking about a audio adapter we made so that you can live stream phone calls from a regular phone into your computer. And this seems like a simple problem, but it's actually pretty complicated, especially if you want to do it wired. If you want to do it over Bluetooth or something, there are a few ways to do it. If you want to do it with an actual cable, there's more to it than you'd think. So Corey and I were trying to do this for another show that we participate in on YouTube so that we could take callers just from the audience. These are people who maybe they're on the go, they can't just call in through StreamYard or whatever your streaming program is, but they can dial in some numbers from their phone, and they're used to doing that for radio shows. So initially, we tried to just use a headphone-to-headphone cable, one of these. Ooh, there we go. 4-segment tip, ring, sleeve, TRRS cable, and that didn't work. And the issue was that the phone didn't see it as a microphone, and neither did the computer. They just got confused. So we did a little bit of digging. I'm gonna show the schematic first here, Corey.
Okay.
We did a little bit of digging, and we found that the phone and the computer want to identify a microphone input. They need to see some impedance to ground. On the mic input, which is the sleeve, it's the S on the TRRS. I'm going to show you guys that. Now, let me configure my screen sharing correctly. Share. There we go. Add to stream. Now you guys can see it. Change the view a little bit. Okay. So, I'm going to zoom this in. You see this TRRS standard right here. So you see microphone is the sleeve, headphone right is the ring, headphone left is headphone right is ring 1, headphone left is tip, and ground is ring 2. So that's, if you read it from the bottom right, it's tip, ring 1, ring 2, sleeve. Okay. Let's move over a little bit here. Here's our schematic. So we have tip. If you look on this highlighted thing here, you see tip, ring, sleeve. Okay, there it is. So here we have 2 headphone jacks, the 4-conductor type. We have one on the left, one on the right, and they're hooked up so that the ring 2 on both of them is configured as ground. So you can see ring 2 is tied on one to ring 2 on the other one, and there's a ground connection. Just a reference designator. There's 2 10K ohm resistors, R1 and R2, and those go 10K from ground to the sleeve. So that's this segment and this segment. Okay, so those go from ground to the sleeve. That is what tells both devices, the computer on one side, the phone on either side, that it's plugged into not just a regular headphone cable, but a microphone headphone cable. And then there's these capacitors in here, and the capacitors are to AC couple the audio. So tip and ring 1 are audio left, audio right. That's this stuff here and this stuff here. It AC couples the audio from the microphone into the speaker input. And that ended up being necessary because there were, the level's supposed to float. It's not supposed to be ground referenced. It's just an AC coupled signal. So anyway, through trial and error, we kind of put the schematic together, and then we made a little version of it. Let me switch back to this view, which is this guy. We made a little circuit board there. Inside there's a couple resistors, a couple capacitors, and then all the wires tying everything together. And on either end are headphone cables. And then you say, well, I don't have a second headphone input and I'm talking on a headset. Well, we use a little USB microphone adapter. There it is. Plug that in and you get another audio device on your laptop, and you can run a second headset to it. So that's how we dial that in. I'm going to get this configured for an actual phone call, and Corey will take you guys through the mechanicals.
Yeah. Let's see. Entire screen. Okay. Is that up?
Yeah, looks good.
Okay. So here is a CAD model for the device that we're building. And I'm going to turn this guy off for a second. So it's a really small PCB, and then it's got a jack on one side and a plug on the other side. And we talked about a couple ways of packaging this for consumers. And because it's such a small case, or it's such a small form factor, putting it in like a little clamshell case or anything that's printed or molded doesn't really make sense. It's pretty expensive to do that kind of stuff, and we're trying to keep the cost as low as we can. So we are looking at potting it, which is filling it with some kind of epoxy. So this pops into, the idea with that is this pops into a mold, which we see here. So there's just some cavities that hold the part and create some space around it. And then there's a little port either on the PCB or in the mold body. And these are usually called gates. And then you inject a liquid epoxy in, and then you have another gate to let the air out, or there's just enough little gaps. And then as it fills up with epoxy, there's a couple little features like right here, you have to interface with the part so that you don't get a bunch of the potting material squirting out or ending up where you don't want it. So this would be a parting line here, and this would prevent, it's like a wall, and it prevents the epoxy from coming out. And then you'd have a top piece that matches the top part of this part of the jack. And so you're playing this problem of trying to contain all the liquid, and then you let it set, and these would get some draft angle like we talked about in our injection molding video. I just drew this pretty quick. So these surfaces would have to be drafted to assist with the release. And then the idea is we would have a big board with like 20 of these cavities. And so we could mix up one batch of potting material, put all the headphone jacks in, and then pour a bunch of them all at once. And then once they're cured, they get popped out. Either they just pull out, or there's like some kind of a pin from the bottom or something like that. And then they're all waterproof, and the potting is depending. There's a bunch of different types of potting material, but you can have them where they actually create a lot of the structure. So if this is plugged into your device and somebody walks across the room and trips on it, it's going to pull a cable out before it damages the board or breaks something or pulls a part off the PCB.
Yeah, exactly. And I have a 3D printed proto you made me. Here, let's go back to this view. It unfortunately became two parts, but basically that is the size of the audio adapter. So it's just the jack to plug into that side, and then this side's the tip. You just plug that into your phone or laptop. Then you just need one cable between the two. And inside of here are those two resistors to tell both devices that they have a microphone plugged in, and the two capacitors, which allow the audio signal to pass from one side to the other while isolating the two voltage levels.
And one thing I want to point out is we looked and we tried software, loopback devices, and all kinds of stuff to get this to work. And I was looking on like YouTube videos, like how to set up your own podcasting studio. And I found this company that was selling, it was like a huge audio board and then like a bunch of cables. And it didn't even work. It just, sorry, it put audio one way. So you could listen to the phone call, but then the caller had to listen from the stream, which we've found is just, it doesn't work. Like
there's a big audio delay.
Yeah, you just can't talk with that much delay. So yeah, we looked and looked because we just wanted to buy the thing that did this and to use it, and it wasn't there, so we had to make it.
We set it up. Yep, that's right. And it actually took a little more doing than we thought. We didn't know how the microphone detection worked, and we didn't know. I forget the reason that we had to AC couple the speaker and the microphone, but there was a reason for that. We got some weird hissing, or there was something weird going on with that. Don't remember what it was. Anyway, we'll play with that when we get the prototypes. We'll do an A/B test and show what happens if you don't AC couple those. So we are dialed in, plugged into my phone. I'm going to add loopback, which is that would be our caller. There we go. Hello. Turn you up here.
Oh, I'm getting a call right now.
What's that?
I'm confused.
Oh, you're getting a call from somebody else?
Yeah, my phone started ringing, so it was just odd.
That's awesome.
Yeah. So
Well,
I'm talking on the phone, and myself and my mic coming back through.
Right. Yeah, you could actually drop out of the stream if you wanted. Here, I'm going to pull you out of the stream just to show that this works. There we go. Still got you there, Corey?
Yep.
Yeah, and it sounds like a phone call, too. It has all that classic audio quality. Cool. So we are going to be producing these guys in some quantity. Probably, we're probably going to do a run of like 50 of them or something like that to start off with. And they'll be on the 9CI store in not too long. And the idea is that you use the little adapter in conjunction with one of these USB audio adapters. So we're going to find some of these that work well and are inexpensive. We're going to make a bundle where you get the cable and the little adapter plug and the USB audio guy. And then you just buy it and poof, you can have callers on your live stream. Or, on your phone conference or whatever. If somebody can only come in by phone and they can't, they don't have a data connection or something, they can't dial in otherwise. It'll work great for that too.
I've had a fair number of people have issues with the audio on Zoom, both on their iPhone and Android. Like the first time it usually doesn't work, and they got to mess with the setting. So
yeah, doing it in software, right? Surprisingly challenging.
Yeah, and if you have the cable is really reliable. So if something else goes wrong and somebody's got to be talking and presenting on something, you just plug them in.
Yep. Yeah, way cool. So we'll do a round 2 when we actually get the devices, and then we'll show what happens if you don't have the resistors and capacitors in there, why you need the little board, basically. And we'll also announce when it's on the store for people to check out.
Yep, great.
Yep, excellent. thank you for joining us for this design stream. We got a whole raft of other ones, a trailer full of other ones, you might say. So look for the next one in probably the next couple days. Thanks for joining us.
See ya.